Okay, so lesson four. So we spent the last lesson looking at metals, and I really liked reading some of the things that you guys chose to look at in your house and some of the realizations you had about what type of metals are more common. It's kind of cool. So now we're going to be talking about nonmetals and metalloids. And even though there's a lot less of them than the metals, they're still pretty prevalent in a lot of things too. So we'll start with nonmetals and some properties. So remember, metals were hard. Most of them were solids at room temperature. They were ductile. They were malleable. With nonmetals, these are usually gases or solids at room temperature. Some of them are liquids like bromine, but typically they're going to be gases or solids at room temperature. And the solid ones are not like metals. They're not like able to be formed into different shapes because they don't have that sea of electrons. They're pretty brittle. So if you hammer at them, they'll either break or turn into some type of powder. And they are not as good at conducting heat or electricity either because, again, they don't have those free electrons that can just move wherever. So they can conduct many of them, but it's just a much slower process. So it's not as effective if you want to make something to conduct electricity. So we're going to talk about hydrogen. Now, hydrogen, again, remember, is in group one, and it was that only element in group one that wasn't a metal. Because again, it reacts similar to some of those because it has that one valence electron. It's going to be extremely reactive, just like the alkali. It's so reactive that, again, similar to the alkali metals, it's going to be very rare to find it ever alone. Typically, when we do find hydrogen, it's in the compound of water, which we know is H2O, and it's a diatomic molecule. So even if you do find it just as hydrogen, it's going to be H2. Diatomic molecules are elements that have two of the same atoms. So a lot of things like oxygen, nitrogen, you will find them as N2. When we talk about chemical bonding more, we'll come back to this idea and when we explain what covalent bonds are. But just know it's a diatomic molecule, and that's what it means. When you find hydrogen, you're going to find H2, unless it's in a compound with something else. Okay, so now the halogens. Group 17, second to last group. Um, so not every single one of these groups we're going to have a name that you're going to need to know, but some familiar names from the periodic table that you need to know now. You know the alkaline and the alkali earth metals. You know the transition metals, the inner transition metals. Now we have our halogens in group 17. Just like group one, these guys are extremely reactive because remember, group one only had one outer electron, so they were just dying to lose it so that they would be full. These guys have seven, so they're just dying for one more so that they can be full. Because remember, the magic number is 8 on that outer shell. So a lot of times they are going to be the ones that react with that group one and take that one that they don't even want. Um, Halogens are used in a lot of things. You can think of like cleaning products. You're probably familiar with a lot of these, like chlorine and fluorine. Other cool things about the halogen group is that a lot of times they will form salts. Now, salts are when you take an acid and a base, and the way that they react, they form a salt. We didn't get to talk too much about that when we were talking about acids and bases because we haven't gotten to chemical reactions yet. But when we get there, we'll come back to that idea and you'll see how a salt forms, but just know it's a product of acid combining with a base. But a lot of times that will involve a halogen. Think table salt NaCl, which is a sodium metal combining with the chlorine from the halogen group. So then we have our noble gases, and they're noble. Everybody wants to be them. They have that full outer shell. So they don't want to react with anyone. They stay pretty isolated. Now you can find compounds that have noble gases in them, but they're not naturally occurring. Naturally, these guys are not going to want to react to anyone because they don't have to. Other people are trying to get to the same configuration that they have. And I just have a picture here because a lot of times they'll be used to make a lot of cool lights, fun things about noble gases. And we'll finish talking about metalloids. So metalloids are like baby metals. Basically, they have properties of metals and some properties of nonmetals. They're in between, which is why when you see those three color-coded parts of the periodic table and you have your metals, your nonmetals, and there's like this little staircase that's like a mix of the colors, and that's because they're a mix of the properties. So they can form ionic and covalent bonds. We'll talk more about that when we get to bonding, but basically that just means they can take an electron or they can share them. They can conduct electricity and heat better than most nonmetals, but nowhere near as well as the metals can. And yes, they're located along that stair-step line that you will see on the periodic table. Now, a lot of the groups along that line are going to be a mix of metals, nonmetals, and metalloids, which is why we don't typically categorize them individually like we do halogens, noble gases, because there's a bunch of different elements within that group, but still they're going to react similarly because of the number of outer electrons they have. So if you know the difference between a metalloid and a nonmetal and a metal and their properties, you're pretty good and know where to find each one. That is lesson 12.4. It was a pretty short one. So there you go.